stands for the International Weather Team, and it's a student-run club. And in this club, we're building and maintaining our weather station on the roof, and we're also encouraging other schools to do that across the nation. And we're communicating with our sister school, Koyu, in Kenya. Other schools would have different sister schools also in that area. So what have we accomplished so far? We've successfully built a working weather station and installed it on the roof of our school. And we've downloaded and analyzed data from that weather station using our computer and Microsoft Excel. And we've set up remote access to the weather station from a computer in our school. But we don't have to go up on the roof to get the data anymore. We've also created an East Junior High Google account for our weather station and a Facebook page for IWT. And also, we're trying to communicate with our sister school in Kenya, but as the station told you, they don't have a computer. So as soon as we get them a computer, we'll be able to get more communications with them.
And as part of the effort to communicate with Kenya, we created a Facebook page. So we'll be starting to post some links and or post some stuff that we're doing. So
if you need any, I already have it up.
So this is our Facebook page, and from your classroom, you can access this. It's on the internet and it's public. So as you can see, we already have a few likes, and we're posting what we're doing. This is a picture of the school code. So that's just a brief overview.
So future goals for the International Weather Team. We want to expand it to Timberline and Boise high schools and get weather stations and sister school programs going there too. And increase communication with Koyu as soon as we get them some sort of computer. And to that end, we're going to fundraise a lot for materials, not just a computer, other stuff too, like they needed a fence for their weather station. And so, and for more long-term goals, we're going to expand IWT all over Northwestern USA with sister schools for each of those schools in sub-Saharan Africa. And also, we want to gain more grants to sustain our growth because we can't buy $1,000 data loggers just on them. And we're also for Africa, we're going to try to use Arduinos, which are small programmable microcontrollers, to experiment with low-cost weather stations.
And we're already starting to experiment with Arduinos this summer. So hopefully in the near future we'll have working.
It's Daniele volunteered. He's got one to take home and they're gone.
How big is IWT planning to get? We'll include schools all the way across the Northwest U.S. and eventually all over the U.S. and also into Canada and Europe, possibly starting with one in the Netherlands. They're already thinking up there of getting one started at University. So what sensors do we have on our weather station? We have our wind direction sensor, a solar sensor, solar panel to charge the battery, tipping bucket to measure the amount of rainfall, and an anemometer or wind speed. Also an air temperature, and inside the box we have a data logger which collects the data, and the battery which powers the station. And Daniel will tell you more about this later.
So I am from the international component, but I have not been able to do much since, as you previously have heard, they have been about to start. They just started their weather station, so yeah, we haven't been able to communicate much. So TAHMO, it's a Trans-African Hydro-Meteorological Observatory, and it's our sister, and we have a sister school there in Nairobi, Kenya. And yeah, we've also collaborators, scientists in the Netherlands as well.
This is a picture of the school.
So TAHMO plans to build 20,000 weather stations across sub-Saharan Africa, and it's trying to maximize the food production and help insurance companies figure out who they want to insure, and as well as the African farmers themselves to make more crops. And then TAHMO is now using East Junior High, or IWT to see if it's possible for their students to run the weather stations themselves. And just here are some pictures from them just working on the weather station out of Africa. So we're now communicating with our sister school, but it's just starting, so we haven't been able to say much.
Oh, hey, Bing, I have to correct, I told you wrong.
Oh.
It's not in Nairobi, it's actually southwest Kenya, near Lake Victoria. Okay, so, sorry, I didn't tell you earlier.
And then it's the school we are communicating with is named KOU Primary School, and we were trying to set up a fundraiser for them, as you previously have heard, to just help them continue upgrade on their weather station there. And originally TAHMO did plan to build low-cost conventional weather stations, but now they are receiving like millions of dollars from USAID in grants, and they can build more precise and complex weather stations. So for the Netherlands, Delft University is TAHMO co-founder and is now trying to initiate a program in Ghana. Delft University has also sent a couple researchers down to Kenya to just test some sensor designs and to see if they will actually work. So here are just some pictures that TAHMO is going to use of the weather station. Here, it's going to be a weather station, and it's just they try to make it as small and like efficient as they possibly can, because the schools out there are not going to be able to really get and going out and fix this expensive weather station.
And also, as you can see, there's no moving parts on the weather station, so it's much more easy to maintain and it's cheaper.
So here are just some pictures from Kenya. So like those pictures up there, these couple pictures here are just the school, and then here's where it's located, and that's the weather station they actually did build. So what do? We actually we've collaborated with KOU, share data, and we make videos on how to build those weather stations. We prepare the sensors, and we just learn about just how to use the electronics. We have actually we go to the roof to check on the weather station, and we have also collected data and weather station and have made map data and graph that, and we also have fun.
So I want to point out there, that's something we started making how-to videos. That would be a huge resource to any school wanting to do this. How they built their air temperature sensor, how they wired their data logger, and as we get into the Arduinos, how we soldered this wire onto the Arduino, every step. That's one thing that's going to be happening in East, because they've got a videography teacher that's, on the program, and it's going to be using videography students to work with the IWT students to make how-to videos. Basically student-to-student videos.
And this picture over here actually is just me and Megan just working on trying to connect the weather station to the computer that we were using.
So an electrician came in and he helped us wire up the weather station on the roof to the school network, so we can access the weather station from any computer in the school.
So the weather station is a facility that's like an instrument and it measures atmospheric conditions. Okay. And we also plan to expand onto Chiang-Mai Boise High, as you've already heard. And this weather station actually took us 5 months to build it, working at a rate of twice a week. And for Boise High, we plan to adopt the weather station that is in the Foothill Learning Center.
So now we're going to move on to more of the technical aspects of our weather station, like all the sensors. So to start off, we have to know what are sensors. The sensors are a device that measures physical property and records it, so we can access the data. And on our weather station, we have 6 sensors. Again, you've already seen this, but we have the solar sensor up here, wind direction, air temperature, back here, solar panel here, wind speed, dipping bucket, data logger, which is in this box. And back here we have the Ethernet plugin, so we can connect to the weather station from any computer in school. Okay, so So how do we collect data? We connect the computer to the data logger using an adapter here. So we directly access the data using a program called LoggerNet. And LoggerNet has been provided us from Campbell Scientific. And we download the data and then analyze it with Excel. So we've created graphs, and it's really interesting to see how our weather station is doing once we put all that work in. The tipping bucket is a device that measures the amount of rainfall. How it works is that this cup is connected to a much larger funnel, and the water falls through the cup and fills the little container here. And after it fills in a certain amount, the water tip will tip. And so by counting the tips, we know how much water is falling. And so the air temperature sensor, it uses a resistor called a thermistor, and it detects changes in air temperature. We'll be building this in your lab, so you'll get to see how it works. The solar sensor records the amount of sunlight, but it does not charge the station. And basically, a metal plate sees how much sunlight there is. And using this, we can tell about how much cloud coverage there is. And so, if our cloud coverage corresponds with our tipping bucket for rain, we know that the sensor is working. The wind direction sensor uses a resistor called a potentiometer, which is the same kind used in the volume knob. When you turn the volume knob, there's a different amount of sound output. So this uses the same concept, but it measures, it's based on the wind. So it measures from 0 to 360 degrees, and we use this in our data. The anemometer, for wind speed, it uses cups to capture the wind, and it rotates. And it sends how many times it rotates every minute to the data logger, and then we convert it to miles per hour. This is the data logger inside the box, opened up. And it's basically a tiny computer that records all of the information from the sensors. We attach a computer to it and then get the data. So we programmed this data logger using the software from LoggerNet, and yeah. Any questions, comments?
How did you contact the school in Kenya? Was that done for you, or how did you contact them?
TAHMO is the organization that organized all this. So TAHMO helped us communicate with them to kind of set everything up. But we have exchanged emails with the principal, and the principal has shown our emails to the students, and they've been really excited. Yeah.
Just out of curiosity, you said you were going to adopt the weather station that was in the foothills front.
Yeah.
Is that station not used anymore? Is that the one up on the way to Eagleson Summit? Hardtack Trail?
Well, it's not constructed yet. So this summer is a fire agency project.
Okay.
They're putting in a new weather station, an automated weather station, just up the hill from the Foothills Center. And so one way an Idaho school can get into this program without spending a year to build their own. There are government agencies with weather stations who would love a school to adopt their station. That agency would provide a mentor, would take IWT students to learn how to maintain the station and get the data to their school. So the adopting a station is an option to building your own station at a school.
Those agencies, by chance, that might have that sort of equipment they would be willing to provide?
I can definitely route you. Yeah, if you tell me where your school is, I can come up with some. I've got the contacts. See, I've been talking to those agencies. We've got kind of a partnership established. They really want this project going forward. And because there's Bureau of Reclamation, there's National Weather Services, fire agencies, a number of agencies with weather stations. And so, yeah, I have all the information on that and the contact people. So if you want to adopt a nearby station, I can help you with that.
I can give you all of their emails if you're all interested in that
I
information.
have it. You know, I have it on paper, but actually, yeah, already in email would be great.
Perfect.
So you said you share data. What do you do with that data? So let's it's cloudy and it rained, how does that translate into information that's beneficial to kids in Kenya or to you? What do you do with the data? You share it, but what is the relevancy behind it?
So right now we're just testing to see if our sensors are working, so
Okay.
to see if the data actually makes sense.
Mhm.
After we know that our sensors are working and our weather station is reliable, we might contact some agencies like the National Weather Service and give our data to them. So our data, we're not going to use our data to predict the weather necessarily right now. So
It helps their models predict the weather better for a location that is providing data.
And so in the future, we're also going to share data with the schools in Africa, but right now,
Yeah.
we're not necessarily.
Yeah, you've asked the great next step question. That's what we're going to do on the pilot project next year. So within East Junior High, the math teacher wants to have the data to teach the students statistical analyses. The computer science application teacher wants to use the data to teach students how to use Excel. There's a lot to do in Excel with data, and the students are learning Excel skills as well as data analysis skills. The biology and earth science teacher want to bring in the data to discuss weather, climate, variability, in ways that mean for the students because they've been there, they experienced that data. And over time, the students have a history of weather patterns at their school. And they can have discussions of climate and trends. And once they become familiar with using their own data and they're comfortable with it, well, let's look at somebody else's data. The math teacher, Mr. Yoakum, he really wanted, he said, I want that COU weather data now. That's what I want to bring into my classroom for the students to look at. I want them to be able to look at the weather data in Africa, because that'll be interesting, it'll be fun for them. Do a statistical analysis on that school's data versus the Idaho school's data, comparison. Maybe that answers the question a little bit.
Do you guys have a barometer on your station?
Not yet, but we plan on expanding our various sensors.
If the chemistry teachers would find barometric pressure valuable for all their gas laws.
Nice. See, that's great. A school-specific need for data. Fantastic.
Go ahead.
Did you find that there were any problems that you encountered in the winter with the snow and the reliability of the measurements?
I don't believe so.
You installed
Yeah,
in April.
Okay.
That's a good question, and that's what they're going to find out.
Yeah.
We were busy building it during the school year in the winter and all that, but we didn't actually get it approved to April, so we'll have to see how that goes this school year.
Just thinking, since you've gone to all the trouble to make this communication, which has been difficult with this school in Kenya, have you brought in outside of STEM, have you thought about bringing in world issue teachers, government type teachers?
Yeah, the geography teacher at East, is it Chipro?
Charles
No.
Mission.
Okay. The geography teacher is very interested. The debate teacher is interested. The English teacher, and in fact, the special ed teachers were very interested. Yeah, the project has those components, and I'm really glad to hear teachers thinking about that.
Just wondering if there's going to be any vision for you to travel to Kenya.
hopefully.
That's possible. That is possible. Yeah.
Are there any more questions?
I don't know. So you guys are doing this kind of as a small club outside of school right now. Do you think it would translate well just into, like an earth science class, like how, like as a group kind of lab, a bigger class, or is it?
I think it could. They could definitely translate that. I mean, we have a lot of graphs that we look at, and it's kind of just like school, almost. Just another classroom.
Yeah.
There's a lot of problem solving and analyzing, so I think it would be perfect for the classroom.
Yeah, a teacher could take any component of a data set or a piece of equipment and present a problem to the students and turn it into a mini lab. You could pose questions such as, well, How does temperature vary with cloud cover? So many questions could be asked, problems posed to students, and now it becomes a lesson. You know, that's their own data. But for example, Scott Johnson, the earth science teacher, he said he's going to choose a group each week, and their job is to do the weather forecast in the school announcements. You know, they have every Wednesday break time, they have their video announcements, and he said, well, we're going to do a weather forecast announcement with updates on how the weather station's doing. So that's going to become part of the school culture. Here's our weather station data. And definitely he's going to be using it in his meteorology section of our science.
So, something that I'm curious about is mentioning 20,000 weather stations around Africa and using that to help you or help them enhance the food supply was mentioned. Is that for just like looking at future and knowing like where to put the crops?
Yeah, that's right.
And also, the insurance companies there aren't really stepping in, because they don't know what the weather's like, so they can't say, oh, I should help that farmer or help that farmer. They need the weather data to say, okay, this is the cost of the insurance and things like that. So, and farmers in Africa, if they have one bad year, they lose everything. So that's also part of the reason why they're not as rich there. So, insurance companies.
Thank you.
There's gonna be years worth of data though, right? And then, sort of like a climate.
You have
graph.
many years of data, but you can do something with 1 year where you can do nothing with no data. Yeah, that's true.